Sometimes your question will not come as what? Draw or what? Derive the shear force and bending moment. Sometimes your question will come as what? Plot the what? The shear force and the bending moment diagram. Now, what should come to your mind is basically what are we seeing in our diagram? The diagram they gave to us has what? 2-point load, which is what? 50 kilonewton and what? 50 kilonewton. And remember, what are we doing here? We have what? Point load. Now, the next thing that should come to your mind is what are the reactions? The reactions will come about your support. So basically, we have two supports. We have the hinge support, which is having two reactions, and the roller support, which is having what? One reaction. Now, the next thing that should come to your mind is how do you now calculate for your reactions? Now, the reactions at this point, which is what? Your hinge support. The one here is for your what? Your roller support. So what you do first is to what? Take a reference point from your diagram. And I told you your reference point will come from your what? Your roller support. So basically, where are we seeing our roller support? At point D. So what? Your reference point will now be at what? At point D. So basically, your reference point is at point what? D. So basically, you're taking D as our reference point. Now, what's the next thing? The next thing is to apply your first concept, which I gave you, that your concept is what? Sum of what? Clockwise moment is equal to sum of anti-clockwise moment. Now, remember, when we are talking about moment, moment is basically what? Force times what? Perpendicular distance. So basically, we are taking our reference point to be at D. So basically, all our moment will come to what? To point D. How do you now take your moment, your clockwise moment? Now, the first thing is you have a reaction here, which is RAY. These are reactions. Now, how do you now take the clockwise moment? You're basically taking this clockwise moment down to what? Your point D. We have this force here. You're taking moments from this point down to point D. We have another force here. We're taking moment from this point down to point D. And the last one is what? The reaction here, which is what? The reaction here will be what? RD, which is already what? 0, because that is our what? Our reference point. So basically, your first concept is what? Concept 1. What is your concept 1? Your concept 1 is what? Summation of what? Clockwise moment is equal to the summation of what? Anti-clockwise moment. Please, when you're writing this in your exam or in your test script, write it in full. Don't write it, don't abbreviate it like this. So basically, this is what? Your clockwise moment, and this is your what? Your anti-clockwise moment, and you're basically taking the sum. So basically, for your clockwise moment, we have what? RAY and what? RD what? Y. So basically, for your clockwise moment, you have RAY, RDY with respect to their what? Distance. That is moment. So basically, we have RAY times what's the distance from this point to this point. So you're basically adding 2 plus 2 plus 2, which is what? 6. Now the next one is sum of the clockwise moment of RD. Since this is our reference point, it doesn't have any what? Distance. So the distance will be what? 0. So basically have plus what? RDY times 0 is equal to, our interest line is the anti-clockwise. Now we basically have 2-point load, and our reference point is at point D. So we are taking the clockwise moment from this point down to what? Point D. So basically we have 2 anti-clockwise moments, and we have what? 50 with respect to what distance? From this point down to this point, we have what? 2 plus 2, which is what? 4. Plus, what's the next one? 50 here with respect to what distance? This distance is what? 2 meters. So we have what? 50 times what? 2. What do we have? This is what? This is 6 RAY. This is what? 6 RAY plus this is already 0. And this is equal to 200 plus what? 100. So we arrive at what? 6 RAY is equal to 300. Divide both sides by what? 6. And you have your RAY to be what? To what? 50 kilonewton. So basically, we've gotten the reaction for RAY. What's the next thing? to get the reaction for RDY. Since the body is small, let's write the value of RAY there. So the value of RAY we got was RAY is simply what? 50 kilonewton. Now the next thing that should come to your mind is how do you now calculate for your second reaction, which is RDY? I gave you concept 2, which is what? Summation of what? Upward force is equal to what? Sum of what? Downward force. The next thing is, what is now your concept 2? Your concept 2 is now what? Sum of what? Sum of up forces is equal to what? The sum of downward what? Forces. So basically, how many up force are we seeing? We are seeing the two reactions moving what? Up, and we are seeing the point load coming down. So basically you have two downward force and what? Two what? Upward force. For your upward force, you have what? RAY plus what? R what? dy, which is this. For your downward force, we have what? 50 kilonewton plus what? The 50 kilonewton, which are in what? Your point load. So basically, we've already gotten RAY to be what? 50 kilonewton. And we don't know what is what? RDY. That's our interest. So basically, this is what? This is equal to 100 kilonewton. Now, for you to get your RDY, you make RDY subject of formula by taking your 50 kilonewton down to what? 100 kilonewton. And what will it be? It will be what? A minus, because it's having what? An imaginary what? Positive side, crossing what? An equal to sign. So you have RDY to be equal to 100 kilonewton minus what? 50 kilonewton. And you are left with what? Your RDY to be equal to what? 50 kilonewton. So basically, you've gotten your RDY, which is what? The reaction here, and it is what? 50 kilonewton. And let's write it down. RDY is equal to what? 50 kilonewton. So you've gotten your two reactions, which is what? This point and this point. What next? The next thing that should come to your mind is how then do we plot the graph for what? Shear force and bending moment. Now, we don't know the values for what we have here. In order to plot the graph, what do? We now do our what? Our shear force calculation and our what? Our bending moment calculation in order for us to plot what? The graph for what? Shear force and bending moment. The first thing that you ask yourself is, we want to get the shear force calculation. We have what? How many points? We have point A, point B, point C, and what? Point D. And all these points, they have what? Forces. So basically, we are going to consider all these points with the forces. That is shear force. When we are talking about force, the shear force, we are not considering the distance. But when we are talking about bending moment, we are considering what? Their distance. So the shear force at point A, the concept is, you are standing at point A. What is the force you are seeing at that point? So we are basically seeing shear force at point A, we have what? RAY, which is equal to what? 15 kilonewton. Now the shear force at your next point, which is at point B. At point B, we have 50 kilonewton. Now, what's the concept? For you to get the shear force at point B, the concept is, you are standing at point B. What's the force you are seeing before that point where you are standing, which is what? At 50 kilonewton. So basically, we are seeing what? RAY before what? The 50 kilonewton. And the 50 kilonewton, where is it acting? Is it acting downward or upward? Now, what we are seeing here is acting what? Downward. So is it what? A negative force. So basically, you have the RAY, which we are seeing with what? Minus what? 50 kilonewton, which is the downward force here. Is a point load, so it's acting downward. So basically, you have this to be what? 50 kilonewton, which is your RAY, minus what? 50 kilonewton, which is already what? Resisting force. And this is equal to 0. The next thing that should come to your mind is, what is the shear force at point C? The shear force at point C. Now, the shear force at point C, what's the concept? You are standing at point C, which is this. What is the force you are seeing before your point C? So you are basically seeing two forces before point C. We are seeing array y and what? Minus what? 50 kilonewton, which is the point load, with what? Your 50 at what point C. So we are basically seeing array y minus your point load minus the point load at what? At point C. So this is 50 minus 50 minus what? 50. And this is equal to, this and this will go out. We are left with what? Minus what? 50 kilonewton. The next thing is shear force at point D. You should ask yourself, I'm standing at point D. What is the force I'm seeing before that point D with what? The force where I'm standing. You're basically standing here. This is you. So you are seeing this force, this force, this force, and the force where you are standing on. So you are basically seeing the force what? Array y with the point load 50 minus another point load again 50 plus what? Because it's an upward force, RDY. And we know that RAY is 50 minus your 50 minus 50, which are the 2-point load, plus what? What is RDY? We already know RDY to be what? 50 kilonewton. So we have what? 50 kilonewton. So this and this is cancelling out. Minus 50 plus 50 is what? 0. So note, shear force at the beginning is always what? The reaction at the beginning. While shear force at the what? At the ending is always what? 0. Now the next thing that should come to your mind is how then do you calculate for your what? Your bending moment. Let's get our what? Our bending moment calculation. Now for bending moment, remember I told you bending moment, you are considering what? The distance. The force with respect to what? Its distance. So the bending moment at point A. What's the concept? The concept behind what? Bending moment is simply what? You are standing at point A. What is the force you are seeing with respect to the distance coming to point A? You are standing here. Since you are standing here, you are looking for that force that is coming to point A with respect to its distance. So basically, since we are standing here, we are not seeing any force coming to point A with respect to what? Its distance. So the bending moment at point A is what? 0. Now, bending moment at point B. What's the concept? The concept is you are standing at point B, which is at 50 kilonewton. You are looking for the force coming to 50 kilonewton with respect to what? Its distance. So you are looking for this force with respect to the distance 2 meters coming to what? Point B. So bending moment at point B is what? Array y times what? What's the distance? From this point to this point is what? 2 meters. We basically have this to be what? 50 times what? 2, which is what? 100 kilonewton. The next one is bending moment at point C. You are standing at point C. You are considering that force with respect to its distance coming to point C. So you are basically seeing two forces. We are seeing array y with respect to what distance now? 2 and 2, which is 4. And what? And this point load, which is a negative 50, multiplying what? The distance, what? 2 meters. So we are considering array y with respect to 4 meters, which is the distance from this place down to point C, minus, because of this downward arrow, 50 times what distance from this point to this point is what? 2 meters. 2 meters. Now what do you have? You simply have this to be what? 50 times 4 minus what? 50 times 2. This is 200 minus what? 100. And is what? 100 kilonewton. And the next one is bending moment at point D. At point D, you are starting at D, at your reference point. What are the forces you are seeing coming to point D with respect to their distance? You're basically seeing array y coming to point D with respect to what distance now? 6. We are saying 50 coming to point D with respect to what distance? 4. And we are seeing the what? The next one, which is what? 50 coming to point D, which is what? 2 meters. So we are seeing what? array y times 6 minus, the minus is because of the downward point load, 50 times what? This case, it is what? 4 minus another point load, 50 minus what? 2. You are left with, this is what? This is 50 times 6 minus 50 times 4 minus 50 times 2. Now, if you do your calculation, this is equal to what? 0.1025. Take this to one decimal point. In fact, take this to a whole number. You have this to be what? 0. So basically, what am I saying? What we are trying to prove out is bending moment at your beginning is always what? 0. And bending moment at the final, which is at your reference point, is always what? 0. So basically, we've gotten the bending moment for point A, for point B, for point C, and for what? Point D. What's the next thing? The next thing is to what? To draw your what? Your bending moment and shear force diagram. For you to draw your bending moment and shear force diagram, the first thing you do is what? You go to a fresh new page. You go to a fresh new page and what? Redraw the diagram that was given to you. After redrawing your diagram, the next thing is use your pen to draw a faint line from your support downward. Use your pen again, draw another faint line downward. Another what? Faint line downward. And another what? Faint line downward. Where are you now drawing the faint line? You are drawing the faint line where you are seeing your what? Your forces. So basically we have one here, another one here, another one here, and the last one here. That's why we are seeing our faint line to be what? 4. The next thing is to pick your pen and draw a thick line. Call that thick line your shear force origin. And you draw another one, you call it your bending moment origin. Now, go back to our shear force calculation. We want to plot the graph for shear force. Now, for your shear force, the first one was what? Shear force at point what? At point A. At this point. And we had what? We had 50 kilonewton. So basically, this is our positive side and this is our negative. For your bending moment, this is your positive and this is your negative. Take note. So the first one is what? Your shear force, which is shear force at point A, and it was what? The reaction, 50 kilonewton. So we have shear force at this point to be 50 kilonewton. So how do you draw it? You draw a horizontal line down to that point. You call this what? 50 kilonewton. The next one was shear force at this point. And what was it? We calculated shear force at this point to be what? 0. So basically, this is our what? Origin to be what? 0. We take it down to this point. You draw horizontal line again down to point C. Now, what's the shear force at point C? At point C, we had minus 50. So you take your minus 50 downward to this point. Let's call this minus 50 kilonewton. And the last one was back to what? Point 0. So this is your point D. Your point D is back to 0. You are taking it up to what? 0. So this is how you draw your what? Your shear force diagram. Now for your bending moment at point A was what? 0. So we have the origin. Now how do you draw your bending moment? Your bending moment at this point is always what? Slanted. So bending moment at point B, we had what? 100 kilonewton. So you slant it to be at this point, and we'll call this to be 100 kilonewton. Now the next one, bending moment at point C. At point C, remember, we had what? Same what? 100 kilonewton. So where will it be? It will be on the same line. So since it's on the same line, what do? You draw a horizontal line across, and from this line down to point D. What's your bending moment at point D? I told you the bending moment at point D, when we calculated, we now got what? 0. So we are going back slanted to what? Point 0. So this is your what? Your bending moment diagram. So basically, this is how you draw your what? Your shear force and your bending moment diagram. Now, what if we are asked to calculate for the origin from point A down to point D? When we want to calculate for the origin, What are we saying? We are asked, sometimes we'll be asked, what is the region from A to B? What's the region from B to C? And what's the region from what? C to D. Now, from point A, we had a what? The region. Now remember, when we are talking about the region, our interest is what? Our interest is what? The distance. So basically, at this point, we can say what? At this point, x is what? 0. At point B, x is now what? 2. Now, at point C, what is now x? At point C, your x will now be what? 2 plus what? 2, which is what? 4. At point D, what is your x? Your x is now equal to what? 6. Because you have what? 2 plus what? 2 plus 2 to give you what? 6. Now, what if you are now asked to get the region AB? Now, for region AB, what do you do? How do you interpret it? Basically, we interpret it to be what? For region AB, we know that what? Our s is what? 0. So how do you interpret it? You interpret it as what? 0 is less than or equal to x, and your x is less than or equal to what? 2, which is this. For region B to C, for region B to C, what are we saying? S is 2. So we have what? This to be what? 2 is less than or equal to what? X to be 2. And this is what? Less than or equal to. What's your point C? Your point C is now what? 4. Now for the last point, at point D, we said what? Point D is what? X is 6. So you'll be asked, what's the region from point C to point D? Now, from point C to point D, how do you interpret it? You basically interpret it in this manner. For your point C to D, we know that what is x? X is 4. So we know that what? 4 is less than or equal to x. To be what? 4. And since your x is 4, x is now less than or equal to, we are considering point D, which is what? 6. So basically, sometimes you'll be asked to what? To get what? The region what? Equation for what? Point A to point B, from point B to point C, and from what? Point C to point D. So how do you interpret it? You interpret it in this manner.